What's up guys? In today's video I'm going to teach you and I'm going to show you how to create a linked list in C. So this is very simple and you are going to see that it's very useful. But first things first, let me explain you what is a linked list. So first of all, a linked list is just a data structure, a way to store data. And let me do a draw with the paint so you are going to be able to see this better. So basically it is called linked because all the elements are linked. So for example, let's say that you have this node in which you store some information. Let's say that the information is stored in this part and then this other part is used to connect to the next element. So for example, if we do this, now we would have here another element in which, again, we have at the left the information and at the right an element that points to another element, and so on, so on, so on. So this is truly useful because you have the elements in this way and it's cool, you know. And for example, let's imagine that this is the last element. This will be pointing to anything. So this would be the structure of a linked list. But you have to know that in this linked list you have two things. You have nodes and then basically just the structure of a linked list which just stores this first node and some information. So for example, how do we see this in C? You're going to see that it's very simple. And here I have these files that, by the way, you have it in GitHub. My GitHub is this. So for example, if you come here, GitHub, Coba, then trading bot, and tutorials, here in C, I don't know where it will, yeah, here, linked list. So here you have those files. So in this node, well, in these C files, what you are going to see is how I developed this linked list. And as you are seeing right now, this is an H file with these public functions. And in this C file, there are private functions related to how to declare nodes and etc. But you can change this if you want. So let's start by seeing how do we create how do we declare the linked list in C. So for example, let's go to the definition of the linked list, and if I go to the linked list.c, here I have the linked list. So as you can see here, we are just storing the root node, what I said here, the first node, and also what I'm storing is the number of nodes. So for example, these would have, the linked list would be something like this, is pointing to this, and also is storing that here we have 3 nodes. So that's what we are doing with this structure linked list. But the important part is here the structure node in which we are storing the information of the node. So for example, here, just to illustrate this, I'm saying that the data is just an integer. But for example, here you could have a string, a dictionary, whatever. And as I said before, you have half of it for the data and the other half is used to point to the next node. So here we have that. So this half is for the data and the other part is pointing to the next node, which obviously this is a pointer of type node because we are pointing at another node. And the same happens in the linked list structure. The first node is a pointer to the node and this is the root node, etc. So how do we handle these things in C? So first of all, how do we create in memory the linked list? For that, I think it's better if we follow this example that I created here. And what I do first is creating the linked list in memory dynamically. So let's go to this function. And as you can see here, first what I do is that I declare a pointer to this linked list, but this linked list still doesn't have anything because we are pointing at anything. So now at nothing, sorry. So now what we have to do is to declare the list in memory. And for that, since this is dynamic, we are going to use the function malloc, and we are going to see that since we just want one linked list, we use malloc with the size of the linked list. And it is as simple as that. This is just for checking that nothing strange happened, and that's it. And also we have to set this variable to 0 because we are starting without any node. So the next thing that I do in this example is, for example, adding a node. And this is important because we have to do several things here. So again, this is for checking errors, that none of these variables are strange or anything. But for example, let's say that we want to add a node. We need to declare a new node. And for that, we receive in this function as an argument the data. And in order to declare this new node, I use this private function that I created in which I create a new node. So let's say here, let's see here, how do I do that? So for example, this is very similar as we are doing it in the linked list. We declare an empty pointer of the node, then we use the function malloc, and then here in the end variable we have the node, but we have to initialize it with the data. So the value is stored here. So once we've done that, we can continue seeing the list, how to add a node in the linked list. So you have to know always that you have to add it at the last place. So for example, if we have this list and we want to add a new node, what we have to do is basically go to the last one and then add it here. So for this, you have several ways to do it. So for example, in the linked list structure, what you could do is to store also the last node, so it is easier and faster for you to access that node whenever you want to add a new node. But this depends on how you want to do it. So I wanted to do it very simple, and yeah. So for example, we have the root node, and now whenever we want to add a new node, what we need is an algorithm that goes to the last node. And this is truly very simple. So for example, what I do is that first I check that there's a node. So for example, if the linked list is empty, what I do is that I just set the root node of the linked list to this node that I created. Otherwise, what I do is I use this algorithm linked list last which is just a while loop, which goes to the last node and returns that node. So for example, if we go to this function, as you can see here, again, error handling. And what I do is that first I set this variable to null. I set this end variable to the root node, and yeah, again, more error checking. What I do now is I iterate over those nodes. So what I'm doing here is that, okay, if we are in this node and the next one is not null, it means that it's not the last. So for example, if we are here and the next of this one is not null, it means that there's a next one. The same happens here, but here, the next one of this is null because there isn't a node. So for example, what we say here is that this one is the last. And what happens is that this condition is met, and what we do is that we go out and we return this last node. So let's continue with the function, and what I do here is that once I get the last, what I do is that the next one of the last is going to contain the new node, and basically that's it. Then I add more nodes and etc. And now let's see, because I think that I do more things. Okay, that's everything I do with the list. You can add more functions such as looking for nodes, ordering, sorting nodes, etc. But I just did that. So for example, let's continue, and you are going to see that now what I do is printing. And in order to print a linked list, you have to iterate over the elements of the list. And how do you do this? Again, with the same method as we did for looking for the last element. But in this case, instead of just returning the last one, what I do is that in each node, I will print the data in it. So for example, this is another way to do it. And instead of checking if the next one is null, what I do is that I check that the one in which I am now is not null. So for example, what I do is that I place myself in the root node, and let's say that the root is here. So what I do is that I print this one, then I go to this one, print this one, go to this one, print this one, go to this one. And now what I do is that I print this one, I go to this one, there's nothing to go there, so I really don't go because this condition is not met. Well, this condition is met, and then I go out of the loop. So that's how I print the linked list, which is a way of just moving through the list. So I think that is everything. So for example, I also have to say how do I destroy the things, but again, this is very simple. The only thing that I do is that again, you have to iterate over the elements of the list, but in this case, you have to be very careful because let's say that you are in this node and you destroy this node without doing anything before. You destroy it. The thing is that now you are not able to access all these nodes because you destroyed this without saving the next one. So you need to save at least the reference to that other one so you later are able to destroy that one. So what we do is that first I save this reference, then I destroy this, and since I have this reference, okay, what I do is that now I save this reference, I destroy this, and since I have this reference, I save this reference, I destroy this, and so on, so on, so on, so on. So that's what I do here. So for example, node to destroy, this is the actual node, and what I do is that I store in N that reference of the new node. So I destroy this one, and now I know that I can continue destroying. And finally, we destroy also the list. And the function node to destroy is just a free of the node. And I think that's everything. Let's see the test and let's see how to compile this, because since we have several files, you may be wondering, hey, how do I compile this? You're going to see that it's very simple. So the .h is just for declaring the public functions which can be used outside of the linked list.c file. So for example, here in the test file, I can use all these functions, but I cannot use the ones related with the node. So for example, if I do this, for example, this function node destroy cannot be used in test.c because it is not declared in the linked list.h file. So let's see the example and let's see how to compile this. So the first thing that we have to do is gcc -o, well, yeah, we can use -o, well, let's use -c. So gcc -c, first, we create the linked list.c file, well, with this we create the linked list.o, and now since we have this, we also need to do that for the test.c. Let's see if this works, okay. And finally, we have to link those O files with the gcc -o. Then we are going to call it this test. We are going to use the test.o and the linked list.o. So as you saw right now, this created this executable, but there's another way to do this, and it's just by simply, let me remove all the .o files and the test, and it is just as simply as doing this. So gcc -o, let's call this test, and now let's use the linked list.c, the test.c, and it is as simple as that. So here you have the executable and you can run it. So for example, let's make the terminal bigger, and if we now execute this test, you can see that now we have the linked list. So for example, we have here the linked list, number of nodes 3, and we have that the first node is the data 1, and it points to the next node, which is the data 2. Again, as you can see, this here is the thing that I did in the example. If you're seeing all these ifs, it's just control error that I will explain in another video. But just to show this, I can do more things. So for example, I can add more elements. So if we do this, and we recompile, and then we re-execute, we see that now we have a lot of 3s. So for example, let's change this last one to 18, and if we recompile and we execute, we see that the last one is an 18. For example, we can change this one to 30, and again, if we recompile and we execute, you see that now this one is 30. So with this video, I wanted to show you the first data structure that I did in the channel, and I hope you enjoyed how to create this data structure. You have the code in GitHub, and you are seeing that it is very simple to declare it, and you can do several things. Like, this is not the only way to declare, well, to implement a linked list. You can also save always to point, well, you can also point the last element, so you can access that element in a faster way. But that will take more memory, but that depends on your design. So I hope you enjoyed the video. I hope you understood how to create a linked list. And if so, give it a like, share, subscribe, and see you in the next one. Estoy bajando todo, lo siento, te quedas en nada.
time.